Okay, so here I am doing a 6-1 sample. I'm going to do the first one in the problem set. This is coming from the lesson 6-1 skill practice. It's the first one in the problem set. It says Eric sells model cars from a booth at a local flea market. He purchases each model car from a distributor for $12. And the flea market charges him a booth fee of $50. Okay, so what are his costs? You have to understand the difference between costs and profit. So, and these are all the problems that you're going to have revolve around the same scenario. The math is the same, the scenarios might change. So, what does it cost him? Well, it costs him his f of x, or y, I'll just put it as y because that's what they do. His costs are $12 per car, and they charge him a booth fee of $50. So those are his costs. Okay, and you'll see what they're talking about. And then the second part is what he makes. He sells them. This would be his profit or income, actually. That would be more appropriate. His income is $20 per car. So we start with some pretty basic and simple functions. And we're going to try to see how long it takes, how many cars does he have to sell to break even with how much it costs to make each car. So that means we put this equation equal to this one. Notice they're both in y-intercept form. So this makes this one relatively easy. So that means we would have 20x is equal to 12x plus 50. Okay? And you can see that equation on the graph. Now, we were talking about solving, finding the break-even point. They're going to graph it. That means they're going to find the y-intercept and the x-intercept. Okay, so let's look at what the y-intercept and x-intercept for the top problem would be, and then you'd put those points on your graph and graph it. There won't be the y-intercept for the first one is at 50, right? Because this is the y-intercept. So that means on their graph, you can see they put the y-intercept at 50, okay, for the one line. Okay, and then they had a slope that is increasing. So obviously your x-intercept will be in the negative. Now, in reality, is that possible? No, it's not possible. But we can find it. And by finding it, we'll be able to graph the line. Okay? Or we can pick another point. It won't make a difference. Okay? And then after we graph that, this would be your old school graph where you went up 12 over 1, up 12 over 1, up 12 over 1, up 12 over 1. Okay, so it would look something like this. Up 12 over 1, up 12 over 1, up 12 over 1. Okay, you had your line increasing. And that's what they have. You could see the expenses. Okay, that's what they did. Now, notice it's very rough and very inaccurate at times because graphs are inaccurate. Graphing can be accurate, but finding the answer from graphing is inaccurate. All right, and then there is no y-intercept for the sales, right? It's 0 because when we don't sell anything, we don't make any money. So there is a 0 from income. And then as we sell them, the slope of that is 20. So that'd be up 20 over 1, up 20 over 1, up 20 over 1, up 20 over 1, up 20 over 1. And obviously that's going to increase faster than our expenses. Okay, and you can see that in the graph that they have. All right, but the problem is after they graph it, they are only estimating the number of cars. Like they can only guesstimate. So when we start with this whole unit, we start with graphing and we graph these things. Now, I can tell you if you carry out the negative, it makes it easier. You find your x-intercept and y-intercept. So my y-intercept was 50. My x-intercept would be negative 50 divided by 12, right? Because we put a 0 in for y and we solve. And negative 50 divided by 12 is going to give us a decimal, but it's at 4.16. So that means at negative 1, 2, 3, 4, you could draw your line and extend it out. And it should be a straight line. Give me a break. I'm trying to draw it freehand. Okay? But you can pick and move all the way up. You notice that you're going to be estimating on the graph of when that is. Now, if you want to double check it, you put them equal to each other, and you get all your x's to one side, so you get minus 12x. You get 8x equals 50. You divide everything by 8. 50 divided by 8, does it go in evenly? It does not. It's 6.25. So he will not break even until he sells how many cars? See, now this is the difference. This is an accurate break-even point, meaning he will break even at exactly 6 1/4 cars. But can he make 1/4 of a car, and can he sell 1/4 of a car? The answer is no. So he will not break even until he sells at least 7. Okay. If he sells 6, he's still losing money. If he sells 7, he's now broken even and he's actually making money. But he cannot break even at 6. He'll be under. He needs to be over 6. So that means his only other option is to sell at least 7. Okay? Again, math answer, real life. Okay? And that is the gist of going through 6-1 and understanding what you're going to be doing. You're going to be graphing, and you're looking for an estimated answer. And then you can use the second part is where you're going to use real life substitution or real life putting equal to each other. Now, they are working on trying to get rid of fractions in this part as well, looking at systems of equations and getting rid of fractions. And we've already talked about how we get rid of fractions, multiplying the whole problem by a denominator. Okay, so they give you the sample problem in 7. Notice the denominators were the same for the first problem and the second problem. That's, or the problem 7, the first half is 1/2 x plus 3/2 y, okay, equals 4. And the other part is 2/3 x plus a negative 1/3 y. Hopefully you know that minusing and plussing and negative are the same. Okay. And this one equals 4, and this one equals 7. In this problem, they multiplied everything by 2. In this problem, they multiplied everything by 3 so that they can get rid of the fractions. All right. If you look at problem 8, this one's a little goofy. The top problem, you'd have to multiply everything by 6, okay? Because 2 doesn't go into 3, 3 doesn't go into 2, so you can't use either one of those. You have to find a common denominator. This is where the addition and subtraction comes back to haunt some of you because, oh, well, you know, common denominators. No, you're gonna have to know how to do them. Okay, just like for problem 9, they're gonna use the number 12 for the top, and of course the bottom one would be 5. Okay, so understanding how to transform equations is important. Okay? If you need to get rid of fractions, you do. You can have decimals. You don't want fractions. You actually don't really want to have decimals either, but we'll go over how to get rid of decimals in class. Okay? And then being able to put them next to each other solving using substitution. I've already gone over that. All right. So we will look at a decimal problem, and then we will be done. I'll go ahead and do a decimal problem. Now, my suggestion would be to change the decimal to the fraction. Most of you should remember how to do that, and then get rid of the fraction. That would be my suggestion. But there are easier ways. So, in other words, how can I move that decimal point over? I'll give you the shortcut reason. Okay, so let's look at this one. We don't want to have decimals because decimals are the same as fractions or similar to. They're just another way of writing it. 1.2y equals 2. How do I get that to be whole numbers? Well, in other words, I need this decimal to move over one time. What number can I multiply this whole problem by that would move that decimal over one place? That's what makes decimals easier than fractions. I can multiply this whole problem by 10. When I multiply by 10, it moves the decimal over one place to the right. So now this becomes 5x plus 12y equals 20. See how easy that is? Moving the decimal is a lot easier than getting rid of a fraction. But you should be able to do both. All right? And that's transforming from one to another. All right, thank you.